Good day. I'm going to discuss tropical design, so sun and the design process. In the design of buildings that makes use of the principles of passive cooling, one essential consideration is to understand solar geometry because the sun's rays upon hitting the earth vary with time and latitude. In concept, a specific site is made static and the sun allowed to move from east to west across the sky. This is technically called celestial sphere. Relationship of the sun and earth. Sun is the main source of light and heat. It is the closest star to earth. Core is 15 million degrees Celsius. Distance to Earth is equivalent to 150 million kilometers. Apparently moves across the sky at the rate of 15.04 degrees per hour. Earth. The Earth revolves in an orbit around the Sun. It takes 365.25 days to complete one revolution around the Sun. Rotates about its polar axis at 360.99 degrees per day as it revolves around the Sun. The period of rotation of the Earth in its axis is 23 hours, 56 minutes, and 4 seconds. The Earth's polar axis is inclined at 23 degrees 47 minutes from a vertical to the Earth's orbital plane. Inclination causes seasonal changes on Earth. Solstice, as defined, either of the 2 points in the ecliptic at which the sun is overhead at the Tropic of Cancer or Capricorn at the summer and winter solstice. Astronomy, either the shortest day of the year, winter solstice, or the longest day of the summer or the summer solstice. It lies on Tropic of Cancer at 23 degrees 27 minutes north latitude. Winter solstice lies on the Tropic of Capricorn at 23 degrees 27 minutes south latitude. Equinox means equal day and night. Occurs twice a year when the tilt of the Earth's axis is inclined neither away from nor towards the sun, the center of the sun being in the same plane as the Earth's equator. At an equinox, the sun is at one of two opposite points on the celestial sphere, where the celestial equator, example, decline 0 degree, meaning it is actually located midway. So an ecliptic intersect this point of intersection are called equinoctorial point, classically the vernal point and the autumnal point. Now, as you can see that the center is the sun. So the center of the solar system is actually the sun. So our planet revolves around it through the aid of this orbit. So let us go over the summer solstice. The month is June 21 to June 22. Incoming solar energy is the greatest in northern hemisphere. While during autumnal equinox, the month is September 23 till September 22, incoming solar energy equal in both hemispheres. So during winter solstice, the month considered here is December 21 and December 22. The incoming solar energy greatest in southern hemisphere. So take note that the Earth is inclined aptly 23 degrees and 1/2 minute. So meaning this one is inclined away from the sun. So here the vernal equinox, the month is March 21 and March 22. The incoming solar energy equal in both hemispheres. So here the Arctic Circle at 66.5 degrees north, and the Tropic of Cancer is 23.5 degrees north of the equator. So when you say equator, it is actually found at the center of our planet. So the Tropic of Cancer, or should you say of Capricorn, is 23.5 degrees found at the south side, which is actually found at the this region, southern region. Now the Tropic of Cancer, this is the equator side. Now if you're going to look at the angle, it is actually tilted 66.5 degrees through north. Okay, now along the equator side, as you can see, this is considered to be the 90 degree. So from north to south. So June 21, while during December 22, as you could see here, this is considered to be the sun's surface, which is found along the if this is considered to be your north, south, it is along the western region. Now the cold side here is at this eastern corner of our planet, which is actually considered to be the Tropic of Capricorn. Note the inclination of the polar axis reaches its maximum on June 21st during the summer solstice, where the sun would be at its farthest northern position. Therefore, June 21st is considered the longest day. During the winter solstice, the inclination draws towards the sun on December 21. The sun is at its nearest northern position. It is on this day where we experience the shortest day. As equinox means equal on March 21st and September 21, both northern and southern hemispheres experience equal amount of solar radiation. During this period, the sun rises and sets directly to the position of east to west respectively. Now let us go over the sun path. So take note that sun rises through east. So let us say that this is 6 o'clock. Once it reaches to AM from east, and then west is actually the sunset throw. So meaning the time allotted here is 6 p.m. So from sunset, take note that during June 21st, it is already considered to be one of the highlights of our solar system that draws heat through the house. So we can avail the solar radiation coming from the sun. So this is already your north, west, your south, which is actually your solar window, and during December 21, it allows, so meaning because the sun is farther from, the sun is located far away from our planet. That is why the angle here is much more lower than during summer. So take note, the angle here is considered to be the sun appears to be nearer to our planet. That's why it appears to be higher. Now, the position of the sun is determined by two angles, the solar altitude angle and the solar azimuth angle. When you say solar altitude angle, we will be able to utilize this because of the height. While for the solar azimuth angle, we can utilize this through the aid of this solar chart, which means that it is reflected in our planet. Now, the solar altitude is the angle, height of the sun measured from the horizon. Above the horizon is the position, below is negative. The sun directly in the center of the sky has a solar altitude of 90 degrees. So meaning the 90 degree is actually this one, considered to be your solar altitude or the height. While the azimuth, solar azimuth is the angular position, the sun measured around the horizon, with northern being 0 degrees, east 90 degrees, south 180 degrees, and west 270 degrees. So meaning your solar azimuth is actually this concentric circle. Latitudes. North 90 degree. So from 90, you could see here that the center of the equator is considered to be your origin, which is 0, 0, or the neutral zone. Then eventually from 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90 degrees. So here, this is considered to be your equator, which is actually the very center of our planet, north and south. So meaning this is west and east. So your west and east is actually considered to be your equatorial site. So factor that determine the amount of solar radiation on Earth, the position of the sun according to time and day, the position of the sun according to the season, clouds, and atmospheric observation or obstructions, the angle of slope of the station, the height of the station, the situation of the station with regards to its surroundings. The solar charts come from the Arabic word meaning azimuth, the direction. It is an angular measurement in a spherical coordinate system. The vector from an observer or the origin to a point of interest is projected perpendicularly onto a reference plane. The angle between the projected vector and a reference vector on the reference plane is called the azimuth. This is an example of a solar chart. Latitude 9 degrees north. Once again, another example of solar chart. Latitude 13 degrees north. Another example of solar chart. Latitude 17 degrees north. Another example of solar chart. Latitude 21st degrees north. Another example of solar chart is latitude 25th degrees north. Another example of solar chart, latitude 29 degrees north. Solar chart, latitude 33 degrees north. So your main living spaces, the main living spaces such as living, family, and dining rooms should be facing north as much as possible. East facing rooms are most suited as kitchen and breakfast areas, as they can benefit from the early morning solar sign or sun throughout the year, and will be cooler in the late afternoon when evening meal prepares to take place. West facing rooms get low angle, late afternoon sun. They usually require some shading to prevent overheating and excessive glare, particularly during the summer. Building orientation, positioning of the building is crucial to maximize energy production in a passive solar home because it relies on natural sunlight to power the building's utilities. It must be oriented on the site in a way that will allow it to maximize the amount of sunlight. The best way is orient the house on east to west axis and concentrate most of the house glazing on the south wall. This allows the home to receive the most direct sunlight for the longest period of time. Solar chart is a design tool required to assess site and building layouts for passive solar design. The resolution of such issues can be achieved from consideration of the angular relationship between the sun, the building, and any shading devices, and obstructing bodies. Such design tools are often manual method. It can be used to assess the degree of shading on the building's facades due to terrain features surrounding buildings, facade projections, and local landscape features. Different approaches exist to analyze the direct solar beam. We have number one is the graphic plots. Number two, the manual trigonometric method. It is rarely used. Number three is computer-based trigonometric methods, often with graphical output. And fourth is scale models examined using a sundial device and natural sunlight or an artificial light source. Establishing the shading angles. Data required. Number one is plan and section of the building should be considered. Number two, sun path diagram of the appropriate latitude. Number three, transparent shadow angle protractor. Number four is you can already overlay the diagram or the azimuth diagram to your plan. Number five is choose the month and the time you wish to consider and note the point of intersection between these two lines. Read off the azimuth. So take note. This is the radiating line on the protractor that passes through the intersection. Number seven, read off the latitude. Note, this is the broken semicircular line on the protractor that passes through the intersection. Number eight is plot the azimuth angle on the plan of the building. Number nine, plot the altitude angle of the section of the building. Number 10, on the plan, sketch in the path of the sun that will be entering the opening at the time of the day and the month of the year that you have been examining. And then number 11, place shadow angle protractor on sun path diagram so that the bow of the protractor is facing the same direction as the opening. Using solar chart 16 degrees. So take note that it will actually depend on the type of chart that you're going to use. So the coordinate is very important to pinpoint the exact location of your site. In that way, you'll be able to utilize the correct solar chart. So take note, different latitudes have different angles. So presuming that our site is located at 16 degrees north, so using the solar chart latitude 16 degrees north, what is the vertical height of a building if the horizontal shadow created by the sun on a certain September 11 time is at 8 o'clock a.m. is approximately 173.20 meters. So you are required to solve for the height of the building. So the area of the building is actually discarded. So using the graphical plot, we would like to determine how high is the building. So using latitude 16 degrees north, so take note that here we have our protractor, which is actually the solar azimuth chart. So meaning, as you could see, that from a protractor, take note that from north, this is already 0 degrees. So 10, 20, 30, 40, 50, 60, 70, 80, till we reach 90 degree. And then from here, you have noticed that from 90, we have 100 degree till it reaches this line, which is actually 180 degrees, till to 70. Once it goes to this angle, it is already considered to be your 360 degrees. So this is already your solar azimuth chart. While for the solar altitude angles, take note that from here, we have actually, we begin from 10 degrees, 20 degrees, 30 degrees, 40, 50, 60, 70, 80, till we reach 90 degree once again. So take note that we need to look at the time and month. So here we have presumed that the problem is September 11. We need to look at the bow, which is actually highlighted in this solar chart. So the intersection at this point to that point is also very important. So meaning we need to highlight these coordinates in such a way that we will be able to see the very center of this chart. Then take note that at this specific month, because from east to west, this is actually considered to be your sun path at this specific month, which is actually September 11. And then the time is actually 6 a.m. from this point. That's why if you're going to look at this is actually 6 a.m. Then 7 a.m. Once again, you will see this line that will serve as our guide from 6, 7, 8 o'clock a.m. This is once again the projection of the sun that is actually reflected in our chart. So at 9 a.m. this is once again the altitude of the sun at 9 a.m. 10, 11, once that it is located at noontime, which is actually considered to be your 12 o'clock, it is found at the very center of this chart. So this is 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, and then this is 6 p.m. So once again, the problem is at 8 o'clock a.m. we need to intersect 8 o'clock a.m. through this bow, or what we call the sun path. Then eventually, the intersection found at this chart, you need to provide here a straight ruler and plot this line. So just drew the line. Eventually, we were able to locate already the bearing, which is for the azimuth, we have 94 degrees. So take note, it is found here. That is why I have noted it that the azimuth angle is 94 degrees. Then, eventually, from this, to determine the altitude angle, you need a compass. So once again, once that you have pivoted your compass, take note that this is the point of the compass and this is the pen of the compass. Once that you plot it, so it actually intersects at this boundary, which is considered to be your altitude angle, which is 32 degrees. So this is how easy and how simple to use this solar chart. So therefore, we need to determine what is actually the height of the building. So we will discard the plan of the building. So for this problem, so take note, the height is unknown. So for the problem, the shadow casted is 173.20 meters. So using 32 degrees, which is actually found in our solar altitude, or known to be the elevation or the height, we put here the angle, which is actually 32 degrees. So height is unknown. Using the tangent of data equals to height equals to, of course, take note that tangent of 32, height is the opposite side, while the adjacent side is 173.20. So therefore, height is equivalent to tangent 32 degrees multiplied by 173.20. Height therefore is 108.23 meters, meaning the building is actually a skyscraper. So from here, we would like to graph carefully how the isometric is shown based on our solution. So take note that the solar angle, which is actually the altitude angle, is 32 degrees. Now, if we're going to plot this from the building, so we have 94 degrees from north to west, or going to northeast. So therefore, shadow casted northwest is 94 degrees. The altitude angle is 32 degrees. So the bearing from south is 86 degrees going to north, or from east it is 4 degrees going south. So this is how we are able to interpret the solution. So take note that the shadow casted from north till west, so take note, northwest is the 90 degrees. That is why from east going to south, we have 4-degree angle. That is why we were able to come up with the azimuth angle, which is actually 94 degrees. So at 8 o'clock a.m., the shadow here casted is 94 degrees. So meaning from here, this is 94 degrees. All you need to do is just draw it at that angle at the opposite side. So meaning the length of the shadow is already reflected in this building, which is actually 173.20. So this is the solution. Slabs. A slab roofing is used in the house instead of a regular steel truss and roofing because of the slab's wind resistive properties. Also, the concrete's ability to insulate the interior area from solar heat makes slab great for reducing indoor temperature gains. Advantages of stilts. Number one, improve wind flow. Ventilation can now be introduced through floor slats in addition to regular windows and clear story windows. So this is the manner how the bahay cube is actually designed. There are bamboo slits that are actually introduced to its floor. In that way, it will allow ventilation to pass through the floor openings. Second is flood protection by raising the house a few meters from the natural ground line. Floodwaters could be easily avoided from reaching the main floor level. And then number three, the advantage of stilts, or in simple layman's term, the silong. It is allotted for future expansion. The void space underneath the house gives the option of adding needed areas in the future, such as sari-sari store or parking area. And then number four, topographic flexibility. Because of the stilts, the house can be built of any type of topography, from sloping terrain to flat. Tropical design. So we need to introduce slotted flooring allows cold air to enter from below the house that then create a stack vent effect, where warm air is forced upward and exits through clear story windows. So what is stack ventilation? The difference of temperature in the air forces warmer air upward by introducing intake window for cold air in the lower part of the window and exits for warmer air in the top part of the window. The stack effect is created, increasing wind flow. This already ends our report.